Hello and welcome to a little video about functions. Let's get started. First, let's discuss relations. Relations are maps, or I guess any types of relationships between a set of input values and output values. We have various ways to represent relations. One of the ways is an ordered pair. Remember, and jot this down if you need to, ordered pairs are always x, comma, y. We also have equations, we've got verbal examples, we've got maps, we've got graphs, and we've got tables. Now, what is a function in particular? A function is a sort of relation that assigns each element of the domain, so the x, the input, exactly one element of the range, so the y. So functions can be represented in various ways, just like relations, but they have to have that special thing about them where each x, or each domain, can only get us one range. So, for number one, let's analyze the table. Let's look at the domain, because the range does not matter in whether or not it's a function. Now the domain, each one of them can only go to one range, which means we should not have any repeating domains. Do we have a repeating domain? We don't. Perfect. So, for number one, we can write, yes, this is a function. Yes, because the domain doesn't repeat. And it's all about that domain. The range could have been the same number all throughout, and it doesn't matter. For number two, let's look at the map. Again, each domain can only go to one range. Do you see that happening? Hopefully, you notice that that doesn't happen. We've got this domain going to two ranges. That's not allowed. So for number two, our map is not a function, so no. Because the domain of 4 goes to two different, let's write that again, different ranges. Usually I don't write in cursive, but I am for the video because it seems like each time I pick up my pen, you hear the clickety-clacking on the screen. So I'm hoping this is a little better. Number three, let's analyze the ordered pairs. Here are ordered pairs. Once again, everything is about the x's, the domain, the input. Our x's are always the first number of an ordered pair. I'm going to highlight them for easier viewing. Do our x's repeat? They do, which means this is not a function. So number three is no, because the x's repeat. So what is the golden rule of functions? Functions cannot have repeating. I'm going to write a bunch of synonyms. Domain / x / input. So functions cannot have repeating domains, x's, inputs. That's all well for numbers, but what about on a graph? Well, on a graph, we can do a vertical line test, where if a vertical line that we draw crosses 2 or more points, then it is not a function. Vertical lines are all x equal lines. That's why this works. Because if x equals more than one thing on our graph, then it is not a function. We can't have that repeating x. So let's check out these graphs and how they look. Now, we can draw a vertical line literally anywhere on the graph. So mine might look different in every class, but that's fine. All right, for letter A, I draw a straight line through the curve of my graph, and it only passes through once. This is a function. For letter B, I'm going to draw my vertical line through the circle, oval, and what is this? Oh, I see what I did. It looks like it passes through twice. Not a function. Letter C is made out of dots, but that doesn't matter. It's still a function. I'm going to draw a line and try that again. I'm going to try to draw a nice straight line here. It looks like it only crosses a point once. Yes, it's a function. Letter D. Let's draw a straight line. It crosses once. Yes, it's a function. Letter E. Oh my gosh, letter E is a vertical line. So that looks like it crosses always, infinitely. Big fat no. And lastly, letter F. Let's draw a line. Only crosses through once. It's a function. Now, all of these graphs, when we graph them, we usually write y equals. But in order for us to state that A, C, D, and F are actually functions, instead of y equals, we use function notation. Function notation is just a way for us to identify things, to label them. The way it's written is f parentheses x, but it's read f of x. And please jot this down. F of x is y. So instead of us having to write down this equation is a function, the equation is y equals blah, 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 we just start it with f of x. That immediately says, this is a function, get to it. All right. So what we're going to practice for the last part of our lesson is evaluating functions. The hardest part is writing them down correctly. I think evaluating you guys are pretty darn good at. For number 5, we're going to evaluate f of 3. The way we're going to do this is by taking this, thank you, cooperate, thank you, OneNote. We're going to take this 3, and we're going to plug it into wherever x was. So instead of f of x equals, we have f of 3 equals. Next, I still have 4, but instead of x, I'm going to put a 3. Now, if I just write a 3 after the 4, it looks like 43. Oh, sorry if you heard that. So instead, I'm going to put parentheses around the 3. That makes a lot more sense. And then minus 6. 4 times 3 is 12. Let me fix this equals. It looks like a z. 12. And 12 minus 6 is 6. Let's write our answer down correctly, though. Our answer is 3, 6. Because usually when we do this, we're looking for points, for coordinates. This is for a graph. We plugged in 3. We got an answer of 6. Let's do the same thing here. You notice how in this problem I called my function g of x? And that's because I'm just, giving us some variety. Now, before color coding existed, we needed to code somehow, or to point out somehow that these functions were all different. So, in order to do that, what mathematicians did is we have the whole alphabet to put a letter in front of x. And that way we can say number 5 is f of x, 6 is g, 7 is h, 8 is j, and they're all different functions. So they're named differently for that reason. Okay, anyways, sorry for the ramble. Let's plug things in. We've got g of 4 equals 2 to the power of 4. And you're not wrong if you put parentheses. I'll put parentheses just to stay consistent, but you really don't need them up there. 2 to the power of 4 is 2 times 2 times 2 times 2, which gives us 16. 16 plus 3 is 19. We've evaluated. Let's write down our answers correctly. It's not a Z, it's an equal sign, Gooman. Okay, there we go. So our answer, 4, 19. We plugged in 4. We got an answer of 19. Number 7, same thing. We're evaluating h of 12. I'm going to take 12 and I'm going to plug it in for each time I see x. So I got h of 12 equals 1/4 stays 1/4. And don't forget to do parentheses. Because if we forget parentheses, this is what it will look like. 1/4 12. That makes no sense. Put parentheses around it. Now it's 1/4 times 12. And we still have the plus 5. Right. 1/4 times 12 is 3. And of course you can use a calculator to solve that. 3 plus 5 gives us 8. So our answer, 12, 8. It's 12, 8 because we plugged in 12. And we got 8 as our answer. I forgot to put a green box around number 6. Okay. Number 8, last evaluation. Let's find j of 4. Just like before, sorry about that noise, we're going to plug 4 into our function. Again, like the other exponent one, we don't really need to put 4 in parentheses here, but let's stay consistent. Alright. 4 to the power of 3 is 4 times 4 times 4, which is 64. And 64 minus 18 is 46. Our answer is 4, 46 because we plugged in 4 and we got an answer of 46. If you still have any questions, please make sure to ask myself or whoever else is helping you with your math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!